So, good morning. Can you all hear me?
Yes, sir.
Okay. So, I think last class, I just given a basic introduction about same concept learning, inductive bias, all these things. Have you all come across? Have you gone through the video? Just a 30 minutes video.
Sir.
So, how many of you gone through the video? Is everyone? Okay. So, what is the what do you mean by concept learning? And can anyone say me what do you mean by concept learning? What do you mean by inductive bias? How inductive bias is related to concept learning? Any answers? With any simple example, even I have told many simple examples, right? Concept learning, then your inductive bias. So your concept learning is set of all possible hypotheses. So this is all your all possible hypothesis is your concept learning, right? Suppose it is very difficult. For example, here there are instances, assume there are instances are 16 instances. Assume there are 16 instances, meaning positive and negative hypothesis. 16. So what is the possible instances? That, so for example, 2 power 5 or 2 power 16, then 2 power 16 are the positive possible instances. What is the possible target concept? Then 2 power, assume this is D. Then 2 power D is your possible target concept. So then 2 power 16. So it is very difficult to check all such target concept with the help of this is concept learning. So very difficult to test all the test cases. So even you take any hacker rank algorithm, all such things, it is completely because of, I mean, yeah, ML algorithms, right? So they will give when when you try to solve the coding challenges, there are different past visible test cases may be there, some few invisible test cases may be there, right? Directly they'll give positive test cases and negative test cases, in which there are few are invisible hidden test cases. So your algorithm, your code should satisfy both. You may see what are the possible test cases given it as a satisfied, but there are some other test cases which are hidden. So you need to satisfy such test cases, right? But we are giving only few test cases. So it is difficult to satisfy or try all the test cases. Maybe the probability of test cases may be high. So what we will do, we will take few sample test cases and we will apply, we will test. That is what we will take few sample test cases. Such here in terms of test cases, here we will say hypothesis. So there are 16 hypotheses were there, out of which I am taking or 2 for yes case and 2 for no case. So meaning positive and negative I am trying. So this is how we are taking few samples for your testing or for evaluating, for learning. Here in terms of learning, for learning a model, we are taking 2 from yes case, 2 from no case. So this type of cases we used to call inductive bias. This is what your inductive bias. We are taking few samples from the positive test cases or negative test or few samples from the possible test cases. That is what for our in order to train our model. That is what inductive bias is all about. That inductive bias, there are two types. One is your inductive and deductive. So inductive we will learn from the experience. Here we learn from the from the expert. We here the second one we learn from the which are experienced experts. So that is what the two categories of inductive bias. This is just for your understanding. Now the other technique is all about decision tree. Decision tree, as you know, decision tree is one of the your supervised learning technique in machine learning, right? So here generally what we used to say, there are, when you say ML, when you say ML, so ML is classified into two categories. One is supervised machine learning and another one is the unsupervised machine learning, right? Then the third one is, as you know, it is reinforcement learning. Here in supervised learning, we have basically we have a classification. Here we have your regression. In unsupervised learning, here we have a clustering. Another one we have association. In classification, we have many techniques. Here one is a decision tree is one of the famous technique. Another one is your random forest is another technique, right? SVM is another technique. So in this, we are going to study about the decision tree first. What is a decision tree? What is the purpose of decision tree? Decision tree, the word stands for in order to make decisions in the classification, right? This is all these algorithms used to classify the instance. How do you classify generally? We will classify the instance by shorting them down in the tree. We have a complex problem. Instead of approaching the complex problem directly, we will divide the problem into small classified instance. So then we will learn the models. So similarly, same here, decision tree are used to classify the instance by shorting them down the tree from the root to some leaf node. So the top node we used to call root. This node we used to call the root. That bottom node we used to call leaves, right? Leaves are our outcomes, are our decisions. That is what we used to say. So each node in the tree specifies as test of some attribute of the instance, and each branch descending from the node corresponds to one of the possible values for the attribute. Each leaf node assigns a classifications. Each leaf node is assigns, we used to call a classifications, right? So in which there are positive and there are negatives. How these decision trees are used in learning. So decision trees generally used in AI and ML in order to in order to get the conclusions which are based on the data, available data from the decisions made in the past. That is what decision tree, that is what the single tail definition, how we will use this. So here we will, our objective is we need to get the conclusion, or we need to get the final outcome. What is the outcome? Then how do you get this outcome? From the past data. From the past data we will get. So with that we can make the decisions. That is what your decision tree is all about. So how do you represent the decision tree? This is a sample decision tree for your rain forecasting problem. So then outlook, as you know, outlook is your root. So here these are all your leaf nodes, right? Leaf nodes we used to call decisions. Here these are all we used to call branches. Branches are outcomes. These are all we used to call features, right? So so this is how the decision tree is represented in terms of ML algorithms, right? What is decision tree in machine learning with the example? Just this is what we explained so far. So then approach to make the decision tree. How do you evaluate this decision tree? Okay, sir, we can go for classification. We will use decision tree. So then how do you draw? We know. Then how do you evaluate? What is the evaluation rubrics? How do you estimate this decision? How do you conclude this decision? So decision tree is evaluated based on the evaluation parameter, which is called the information gain, right? So information gain is the parameter which is used to evaluate the best classifier in the decision tree. So this is the attribute. This is the parameter which is used to evaluate your classifier based on the value. So here we will use, there is a purity, based on the purity, measure of purity is called information. What is that information? Information meaning the perfect data, The best classifier, the measure of purity is called information here. Okay. So then if you say purity, so just this all I added with the for your understanding. Purity, pure. What is a pure of data? And somewhere in the machine learning, wherever you use read the book, you may see pure data, impure data. What is a pure data? Pure data is nothing but the selected samples of data set which are all belongs to same class. For example, all belongs to S class. Then you can say that is same case. Suppose here it has both yes case and no case. Then this is data is mixture of different cases, that is impure data, both positive and negative examples. So positive test case and negative test cases, that is what you have pure and impure, right? So with this we can calculate the Gini impurity. Gini impurity is also the one of the parameter for ML algorithm. The first class I told you how we evaluate the ML algorithm. There are different parameters, precision and recall, right? Accuracy, F score, pure, impure, Gini impurity, entropy, information gain, and I attribute, likelihood. So these are the different evaluation parameters which is used to evaluate your learning model, right? So suppose Gini impurity is calculated based on the likelihood parameter. So what is the likelihood? Likelihood is also the probability of probability of the data set which are given for the learning. That is your likelihood, right? So suppose if your data set is pure, then the likelihood of incorrect classification becomes 0. Then if it is impure, then we can say it is incorrect classification is 1. So when you say pure, then the classification rate is 0. So if it is impure, we can make it as 1. That is what Gini impurity value is. This is maybe used in upcoming classes. We'll see. So these are all the basics you should know how the decision tree is works. Now, how do you build the decision tree first? As we know how to draw, where to start from the root, then we need to end up with the leaf nodes. So so that is given in the by step. First, you test all the attributes and select one that would be function as the best root. So that is what the first is one is the fixing the best root. That is the first step. The second step is break up the training set into the subsets based on the branches of the root. So based on this root, divide this into 2. Okay. Then test the remaining attributes to see which one fits the best underneath the branches of the root. Then take the test set or test data set. Then check so whether it will go to left side, whether it is suitable for left side or right side. So then accordingly you add the branches. Create a branches and add. So this continue the same process for all other branches until all examples of subsets are one type, meaning once it gets over, there are no examples left and there are no more attribute, meaning until you reach the last one, you continue the same. Suppose once you reach the last one, then you stop the process. This is what your decision tree is all about. In data structure, you might have studied hierarchical data structure, right? Same. Which is nothing but trees, right? So that is what the decision tree is all about. The same trees only, nothing but the way we approach is different. When to consider this decision tree? Instances are represented by the attribute value pairs. So then whenever we have attribute value pairs, then we can go with the decision tree. Then the second one, target function has discrete output values. So here there should be always discrete output values. Your target function, last function, outcome. Disjunctive descriptions may be recovered and condition may be recovered. The training data may contain error, then you can go for decision tree. The training data may contain missing attributes, then you can go to decision tree. Decision tree learning has been applied to the problem such as learning to classify. So then we can go to the decision tree. So these are the possible scenarios when we will choose the decision tree. Which attribute is the best? We would like to select the attribute that is most useful for classifying the example. So how do you calculate? How do you identify which attribute is the best? So at the end of this club, we will see the problem. Information gain, as I told you, information gain is one of the main evaluation parameter in order to identify your classifier, best classifier, right? So information gain measures how well given attributes separates the training example according to their target classification. Here we will say information gain is a reduction in entropy or surprise by transforming the data set and is often used in training decisions. So this information gain is calculated by comparing the entropy of the data set before and after transformation. So the entropy should be calculated. Then from the entropy, you can compare both the entropy values. Then one which has higher value, then you can say that that is the best classifier. That is information gain. ID3 uses iterative decision tree. ID meaning iterative decision tree or induction decision tree, inductive decision tree. So this inductive decision tree uses this information gain measure to select among the candidate attributes at each step while growing the tree. In order to define the information gain precisely, we use measure commonly used in the information theory called entropy. So if you want to evaluate this information gain, then you need two parameters. So sorry, you need a parameter called entropy. This entropy should be calculated based on the positive examples and the negative examples. Right? We will see. So this entropy gives you the amount of uncertainty in the data set at the end. So both purity and impurity of collection of data sets. This is what your entropy is all about. First, I'll show you the formula, then we'll move on to the problem. For example, see, this is the entropy of the samples. Entropy of S is calculated. So S is a collection. So S is a given collection. So collection of data, so either 24 or 10 or 25 data sets. Collection S. So containing positive and negative examples of the some target concept. Target concept may be anything like iPhone or animals, something like that. So anything. So the entropy of S related to the boolean's classification, because at the end we are going with yes or no. So entropy can be calculated with help of positive example, negative example. So entropy of S is nothing but minus P, the proportion of negative example divided by positive plus negative log again positive by positive plus negative samples minus. So you are considering the positives minus the negatives, right? So n by p plus n log 2 and n by p plus n by. So here this is completely p per component. This is your negative component, right? So this is the entropy formula. So when you solve, we will come to know. Right? Then information gain is nothing but the entropy minus I attribute is your information gain, right? So this I attribute is nothing but summation of sum of all the positive and negative samples into multiply with the entropy. When you multiply with the entropy, that you will get. So that entropy function we know, this is your entropy formula, right? So now you just note anyway, you can note down the problem. So now we need this is the problem given. A1 is equal to question mark and A2 is equal to question mark. So 29 plus 35 minus, what do you mean by this? This is your positive positive hypothesis. This is your negative hypothesis. Yes or no? This is your negative hypothesis. Where do I get this 29 plus and 35 plus? From the table. We have done problems, no? Finders algorithm, candidates algorithm. In that, yeah, the target concept which are yes is 29, the which are no is 35. So all put together you calculate 20 plus 30, 50, 59, 59 and 64 instances are there in this problem. 64 rows. Then here we have two branches, true or false. Here the true meaning the positive samples are 21 positives. In this case, this is nothing but your branch, right? So in that we have many like in Scunny, I mean in your the previous example where forecasting example, rain forecasting, it may be a sunny, this may be a sky, another may be a humidity, another may be a climate, something, right? So out of in this we have a true or false. true is nothing but now some case. It is not like only positive. In this branch, you have two category, 21 plus and 5 minus. So here 26 instances were there. Here 38 instances were there. When you add both, you will get 64 instances. That is what this one. Okay. So now they are asking whether this is best, which is a best classifier. 29 plus or sorry, A1 or A2. So A1 you have here 26 and 64 here, whereas in same scenario with other test cases are different. 18 plus 33, 18 plus 33, how much? 30 plus 40, 48, 52 in this case, here 13 in this case. So 50, 60, 64 totally. So whether this is best classifier, 26 plus 38 best classifier, or 58, 13 positive and negative samples are best classifier, that you should identify with the decision tree algorithm. So you will get a question like this only. Okay. So now you can see, so entropy formula, you know, so minus P by P plus N log 2 of P by P plus N minus positive minus negative. Okay. Now the entropy is, so now what we need to do, you need to calculate the entropy function for all these cases. So where is it? So 9 plus 5, where is it is? So I think this is some other, this is an example. Okay, we'll go to problem here. Okay, leave it. So now how do you calculate the entropy here? This is for samples given. For example, entropy of 9 plus and 5 minus. Then how do you calculate? So minus P by P plus N. P is nothing but positive. 9 by 9 plus 5, 14. Log 2 of again 9 by 14 minus negative test case. This is your all your positive test cases. In the what do you call the numerator, the denominator is positive plus negative. So here this is your negative test cases. Negative test cases 5 by 14 into log 10 log of again 5 by 14. So when you calculate entropy value is 940. Same next sample 12 plus 4 minus 12 plus 5 minus. So you will, when you calculate like this, you will get like all these things. So whenever you get log 0, then it will be a 0. When you say log 1, it will be 1, right? So that you just take care. So this is how the entropy can be calculated, right? This is sample values, how to calculate entropies. Calculate the average information theory. So calculate the average information theory. Sorry, entropy. So this is we are calculating just average entropy. So how do you calculate this? So summation of all the positives and negative, P plus N divided by P plus N into entropy. So you add all the positive and negatives into all the entropy value which are calculated previously. So entropy means measure of the impurity in the collection of training samples. That is what the entropy is all about. Impurity meaning, I told you, it is the data set with mixture of the different classes. That is why we are calculating entropy, because it has both positive and negatives. This hypothesis. That is why we are calculating entropy values. Information gain is a measure of the effectiveness of the attribute in classifying the training data. That is what information gain. So the measure is expected reduction in entropy by partitioning the examples according to an attribute. Differences in entropy before and after splitting the data set of attribute A. So gain is nothing but entropy minus I attribute, or else you can add the sum of all the entropy values, sorry, attribute values multiply with the your entropies. Now we will go to the problem. So the first problem, 29 plus 35. 29 plus 35 minus. Consider attributes A and B. So possible values for A and B is small a, small b here. So here it is C and D. Okay. So now we will calculate the entropy value. 29 plus 35. For 29 plus 35, we know 29. First we need to take the positive case. 29 divided by 29 plus 35. So 64. Log 2 of 29 by 64. Same case. Minus negative case, right? So negative is nothing but 35 minus. So 35 by 64, 35, 64. When you calculate this, you'll be getting minus 9.9. So it's a less than 1. Okay. So similarly, you should calculate for the all other values 21 plus and 5 minus, 8 plus and 30 minus. Similarly, now the A is classified into small a and small b. Here you have 21 plus 5, here 26, here 38. So how much? 50, 50, 58, 64 is your overall instance. Okay. So now here also same. 18, 8, 30, 40, 48, 52. I think both the same problem. So then this is your 64. Okay. So now you go for the calculation, entropy calculation. So when you calculate with the same method, this for root node is 0.9. Here for the root node, same 0.9. Here with the 21 plus 5 minus, 21 positive cases, 5 negative cases. When you calculate the entropy, it is 0.71. Same 8 plus 30 minus, entropy is nothing but 0.74. Right. So now what we will do, how do you calculate the gain? I told you this value 21 positive cases, 21 plus 5, 26 divided by both positive and negative, 26 into the entropy value. So gain is nothing but entropy of S, or else your entropy of S minus I attribute. So either I can go with anyone. So now this entropy of S is nothing but summation of your positive minus negative. So now 26 minus 64, 26 minus 64 into entropy of 21 plus 5 minus this value. I am calculating for this minus left branch minus right branch. Your definition says here, you can see the information gain is calculated by comparing the entropy of the data set before and after transformation. So before and after transformation, here you can say it is before is positive and negative. So 26 by 64 into entropy of 21 plus 5 minus. So entropy of 21 plus 5 minus. So here we can write 26 divided by 64 minus 26 divided by 64 into 21 5 minus entropy is 0.71. This is one bracket minus 3864 into entropy of 0.74. When you do it, you'll get 0.27. So this is your gain of this best classifier. Sorry, gain of this 29 plus 35. Similarly, here there are two problems. Here the same 64 instances are divided into 58 and 13, right? So 58 and 13. Here if you take the entropy 94 and 62. So when you calculate, when you subtract these two with the positive and negative cases, you will get 12. 0.12. Okay, it is 0.27. So now from this you can say A provides greater information gain than B. So there are 0.25 into multiply by 100, 27%. This is 12%. So A provides greater information gain based on rather than the B. So we can say A is the best classifier than B. Okay. So this is 27. This is 12. So this data set, A data set, which has 26 positive hypothesis, 38 negative hypothesis, gives you high information gain. So this is your best classifier for classification. So we should not go with 52 and 13. So here 26 and 38 is more or less balanced in both left and right child. But here left child is heavy. 52 instance are positive, negative is very less, only 13. So it should not go like that. That is what our problem also says. So A provides more greater information gain than the B. So accordingly we can work out. Okay. So now the simple logic is calculate the entropy. After calculating the entropy, Then check with the positive and negative. Positive test cases into entropy minus negative test cases into entropy. This is your best classifier calculation using your decision tree. So now I'll give you one example so you can try. So you can just note down this. No, you no need to note down the table. So from the table, so for example, in exam, we will give you the table. From the table, you need to identify, you need to pick the classifier is totally here 14 instances out of 14. How many are positive? How many are negative? See here, this is 1 positive, 2 positive, 3 positive, 4 positive, 5 positive, 6 positive, 7, 8, 9 positive. So totally 9 plus and 1, 2, 3, 4, 5 negative. So this is what this instance. That's what they have written. This is what you need to create a problem. So now 9 plus and 5 minus. Now you can go ahead with the problem. Now you just calculate for outlook and rainy and overcast. So there are three categories. I want to calculate the decision. I want to take a decision based on this outlook. I have a sunny, overcast and rainy. So there are three parameters. So I want to calculate for decision for outlook parameter. So now I'll give you an idea. Calculate the entropy for each value, sunny and rainy. So totally 9 plus and 5 minus. So this is entropy value of root. Root value is calculated 0.940. Now calculate the entropy value for sunny, rainy and overcast. Sunny, outlook rainy and outlook overcast. So here how many are playing tennis? 3 and 2. So you can say sunny how many yes and how many no. Since sunny there are 2 no's and 3 no's and 2 yes. See here sunny P is nothing but positive, N is nothing but negative. So 2 yes, 3 no. Same rainy there are 3 yes, 2 no. Again overcast all yes, there is no. So now calculate whenever past negatives are 0, obviously log 0, I told you it is 0. When you multiply with the entropy, 0 with entropy, this is also 0. So this is 0. So now the sunny and rainy, the entropy value is calculated. Meaning this is your 2 plus 3 minus for sunny. Calculate how much. Again this one rainy 3 plus and 3 plus. Sorry 3 minus. So this is also same. You are getting totally entropy value is 0.971, 0.971. When you multiply with this sunny and overcast and rain. So here the sunny I told you it is 2 plus and 3 minus. Here overcast 4 plus 0, rainy 3 plus 2 minus. So for this entropy value is 0.971. This is 0. This is same 0.971. Both sunny and rainy your entropy values are same. So now what I am doing, so I am just calculating with my value. My entropy value is 0.90. Either you can bring here front and back. So 5 by 2 plus 3 is 5. 5 by 14, right? Overall. So 5 plus 4, 9. 9 plus 4 is 14. So that is what this 14. Positive is 5 by 14 into 0.94, your main entropy multiplication into first entropy. This is entropy of sunny. Then the second one entropy of outlook is overcast is same point. What do you call? Where is it? 0.971 minus 4 by 14. This is not sunny, overcast. This is overcast. Then this is last one is 5 by 4 is rain. 5 by into 971. So this is what sunny and overcast and rain. So now this is 0.247 value, right? Same. You calculate the I value here for outlook. Then finally you calculate the gain for S and outlook. So you minus it, just perform negation, you will get 0.247. Same you calculate for humidity and wind. So you will get a gain of 51, so 0.151, 0.148. Then you compare all the gains. You compare for again temperature 0.209. So finally pick the highest. For outlook, the gain is 0.24. Then temperature 0.29, humidity 0.152, windy is 0.048. So finally the highest one is 0.247. So the best root node is outlook is the best root node, best decision tree classification. So whatever there under the outlook, all the branches are the best in the classifiers. This is what your decision tree is all about. The best attribute now is your outlook is your best attribute here. Same here, other examples given. Repeat the same thing for the subtrees till we get the tree. Here same thing, even if you try p is equal to 2, n is equal to 3, positives are 2 and 3. So then the entropy value for Sunny is calculated. Sunny is totally a 5 attribute. Then entropy is 0.970. Then gain is nothing but, for humidity they have calculated high and normal. There are 0 plus 3. So entropy is also 0. Whenever 0 is coming, obviously we get 0. So humidity calculation. Then your Sunny is positive test cases divided by negative test cases, minus humidity is positive and negative. So this is humidity is completely 0. So only the your Sunny is 970 will come. Thus in Sunny is 970 will come. The same given is for Sunny and wind comparison. Again temperature comparison. So humidity. So you will get, here you can see the wind will be selected. Wind has 0.971. Humidity 0.20, temperature is 0.20, wind has 0.971. So for this, wind is selected. So in this case, see the best route, outlook is selected here. Then wind is selected. Then its leaf nodes are yes and no. In this case, Sunny case, here they have selected the humidities, right? So the main thing is, so which classifier is the best one? So either a humidity or a wind, which has the best highest value that can be selected for the classification. Now you can consider this example and you can try it in home. So this I'll upload the PPT. So next one is car problem is given. So now you can take here how many positive and negatives. So red color cars and blue color cars and green color cars. So how many positives and negative classes? So from this table you create your own instance and you can try, right? Just to take a screenshot of this and you can try it out in home. So that's all about your decision trees. So how to convert the decision trees into rules that we know. I told you in the last class, we need to use the conjunction and disjunctions, right? So if outlook is equal to Sunny, if outlook is equal to Sunny and humidity is equal to high, then you can play tennis. So this is what playing a tennis possibility. Outlook Sunny. So how do you make a rule? Outlook is equal to Sunny, right? These are the your outcomes. Outlook or outcome is Sunny. Humidity outcome is normal, or humidity outcome is high. This is not high. It should be normal. If it is a high, you cannot play tennis. No. Suppose outlook is Sunny, humidity is normal, then you can play tennis. That is yes. So this is how you can make the rules. Then outlook is overcast, then you can directly play tennis. Yes. Outlook is rain, then and wind is equal to strong, then you cannot play tennis. Then outlook is equal to rain and wind is equal to weak, then you can play tennis. So this is how you can make the rule. So rule one is nothing but if rule to R1, R2. So you sometime after constructing your decision tree, you may be asked to form a rules. Then this is the your rule, right? So this is what your this is decision trees. Okay. So in home you can try this. So I'll upload this PPT. You can try this problem, car problem, so that you can come up with the answer. So go through the problem. There are 2 to 3 problems given in this slide. So you can go through the problem and come up with the answers. Okay. So first unit is going lengthy. So still you have ensemble algorithms and a random forest. So let's see. So we'll go one by one. Okay. Yes, you all can leave. Thank you.